Alright, today I'm going to show you how to graph an inequality. So you probably remember the inequality symbols. This one is greater than. And this one is less than. And then there's two others. This one is greater than or equal to. And then this one is less than or equal to. So if I said you must be at least 3 feet tall to ride this ride, I could write that out as you must be greater than or equal to 3 feet. What it's saying is it's okay to be 3 feet to ride the ride. On the other hand, if I said you must have more than $100 to buy a sailboat, I would write that as more than 100, greater than 100. You can't have 100. You have to have more than that. Right? So these kind of have different meanings. This one is kind of like more than, would be another way of saying it. This one is kind of like at least, is another way of saying it. And this one is kind of like at most, is another way of saying it. So let's practice reading these for a second. How would you read that? 3 is greater than 2. How would you read this?
11 is greater than 4.
Less than 11.
Yeah, so although Luca's hitting on a point, this could be read as 7 is less than 11. You could also say 11 is greater than 7. That's totally fine. This is the only case where you can read backwards in English. Right? If I write most words in English, it doesn't make any sense if I read them backwards. With these, you can read this backwards. 11 is greater than 7. 7 is less than 11. 3 is greater than 2. 2 is less than 3. How would you read this one? How would you read that? X is greater than 4. How would you read this one? X? Is this a greater than symbol or a less than symbol?
Or equal to.
Less than or equal to? X is less than or equal to 0. X is greater than 4. It also means 4 is less than X. 0 is greater than or equal to X. You could read it that way if you wanted to, right? So you could flip this around. This means this as well. And this also means this. Just make sure that the point always points in the same direction. So it points towards the 4. Points towards the X. If you're gonna flip them around. Alright, so you guys can read these. Now the next trick is, how do you graph something like this? Yeah. Just plain old equals. We're not going to talk about that one today. Alright. So, you have seen this before.
I like my marker. Number line.
Yeah, what is this called?
Number line.
Okay, that should be good. That's called a number line. The way that you're going to graph these is just using a number line. So if I give you a problem like this, x is greater than 7. Here's what you're going to do. You're going to find 7 on your number line. It's right here. Now, if you have greater than or less than, these are going to be a hollow dot on your number line. If you have the equal to, that's going to be a solid dot on your number line. What kind of a dot am I going to use for this one? Hollow or solid? Hollow. So at 7, I'm going to put a hollow dot like that.
Why?
You can also do it above up here if you want to. Either way is fine. So there's two ways of doing this. Now the reason we put a hollow dot is because x can't actually be 7. So we're putting a dot there that's hollow to show it starts at 7, but it doesn't include 7. Then we're going to draw an arrow to show everything that x could be. So which way do you think our arrow is going to go on this graph? Could x be 6? Or 5? No, because those numbers are not greater than 7. So I don't want my arrow going that way. I want my arrow going
That way. You're right.
showing everything that x could be.
We sort of learned this in like in 6th grade.
Cool.
No?
Now, one really useful trick, as long as you write x first, the way this points is the way your arrow will point. So do you guys see this? I wrote this here like x is greater than 7. This points the same way as my arrow, which is a useful trick. Okay, let's do another one. X is less than or equal to -1.
It's gonna be solid.
So first I'm going to find -1. I'm going to make a solid dot. Why solid?
Because it is or equal.
Yeah, because it's equal to. So that includes -1. -1 is okay, so it's filled in.
So negatives are solids?
Which way is my arrow going to point?
That way. To your left. Nowhere. Right.
X is
No,
first, so
it stays
this
there.
points the way of my arrow. Points this way. Because x could be less than -1. Is 0 less than -1?
No.
No. So it's not going to go that way. But -2 is less than -1, right? So I have to include that with my arrow.
So solid dots are negative?
Solid dots mean you had the equal to.
Oh, okay.
You see on the
Yeah, I see.
Yeah, the solid dot.
X is greater than or equal to -3. What am I going to do? So here's 0. I want to find -3. What kind of a dot am I going to put?
Solid.
Solid. Which way am I going to point my arrow?
That way.
This way to your right.
Is it going to include 0 or not include 0?
Wait, what?
Is it going to go towards 0 or away from 0?
Away.
Towards.
Towards 0. Because 0 is greater than -3.
Yeah.
And because my arrow points this way. Right?
Yeah.
So everything that's greater than -3. Any number bigger than -3. Okay? There's a couple tricks here. The first trick is this. If I have the number first, it's a little bit tricky to draw my arrow the way that we've been doing. So I'm still going to draw my number line. Here's 0, 1, 2, 3. Here's 3.
It's gonna go that way.
Am I going to do a hollow dot or a solid dot? Hollow, because it's not equal to. But now this looks like it's pointing this way, right?
Yeah.
But that's because the number is first. So let's rewrite this. Instead of 3 is less than x, what could I write? X greater than 3. And now I see that my arrow has to point this way.
Oh, wow.
So I would take the time to rewrite these so that your variable is first in all cases.
Also, if it doesn't have a negative in the equation, then you're supposed to do the opposite. It's more original.
Doesn't matter if there's a negative. So if I had negative 5 is greater than x, greater than or equal to, I'm still going to do the same thing. I'm going to rewrite this. What am I going to write? X is less than or equal to negative 5. Right? So I can see that this thing is still pointing towards my x up here. Now when I graph it, I'm going to find negative 5. Solid dot, hollow dot.
Solid.
Solid. Which way is my arrow going to go?
That way.
It's going to go this way, the way
that's
of
what I was
this
reading the top.
thing. Right. And when we want to stop and think about it. So this says that negative 5 is greater than, let's even just look at the top. Negative 5 is greater than x, or greater than or equal to. So does that mean if x were like over here somewhere, let's say if x were 1, negative 1, is negative 5 greater than negative 1? That's not true, so we know we don't want to go this way. So you can kind of figure it out by looking at your values here. This would be 0. If I went this way, is 0 going to work in this? Is negative 5 greater than 0? No. It's less than. So I know that if I made my arrow go this way, that's wrong. I know that that's wrong because these values don't work in this inequality. But on the other hand, if I pick something over here, like let's say I pick negative 10, that's way over here somewhere. Is negative 5 greater than negative 10? Yeah, negative 5 is more than negative 10. So I know that this arrow is a good arrow.
Is this
It's
0?
going the right way because these values are true in my inequality.
Does the 0 always have to go first?
Oh yeah, you always start a number line around 0.
Okay, I just need to.
Yeah.
That helps.
Or, I mean, I guess you wouldn't have to, but it's just a good thing to start with. It's like a place to orient you. Like there's 0. Now I'm going to count from there. Okay? That's it. That is it. Any other questions?
Let's do some